Okay, so this is the feedback for some of the problems in the assignment theorems one. If you remember, they were asking you to prove a lot of stuff related to circle, chords, and tangents and arcs. So we're going to review some of the problems. I just took like 5, I think. So we can review those. So it says complete the proof. AB is a diameter, so this here is a diameter of circle O. Given AC or line AC and line BD are tangents, prove that AC and BD are parallels. Well, if we make a plan for this first, we know that this is a diameter, and we know that at the point of tangency, we always have a 90-degree angle, right? So this works for both. We also know from previous sections that when we have a line or a segment, this is a line too. If you stretch it a little bit further, you know that this is a line. And we know that if we have a line that is perpendicular, because we have that both angles are 90 degrees, if they are perpendicular, then the two lines must be parallel. So we're going to use that theorem to prove it. Okay, so we have statements. Let's put it here. So we have statements, and we have our reasons, right? Our first is our given that AC, line AC, and line BD are tangents. Tangents. This is our. Let's put it here. This is our given. Second, like I said, since it's a diameter, we know a theorem that states that this line, it forms a 90-degree angle at the point of tangency with line AC. So we know that AC, it's perpendicular to AB. Also, by the same thing, by the same theorem, we know that segment AB, we know that line BD, it's perpendicular to AB. This is because diameter is perpendicular to a tangent line at the point of tangency. The point, well, actually to a tangent line. It's obvious that it's going to be on the point of tangency. All right. So number 3, we know that since the two lines are perpendicular to the same line, to the same diameter, then they're parallel to each other. So AC, line AC, must be parallel to line BD. Right? Why is this? Because two lines perpendicular to the same line or segment or whatever, to the same line, are parallel to each other. Right? So that's it. That's how you prove this. Let's move forward to the next one. It says complete the proof. Given RS, this is RS. All right. It's tangent to circle A and to circle B at points R and S. Then prove that the two line segments are parallel. Well, immediately you notice that it's basically the same thing, right? So we have our statements. I don't think that we need to state a plan, right? Because we know that the segment it's perpendicular to RS, and BS is perpendicular to RS because they're tangents. That is like the magic word. Magic word is that if they're tangents, then they form a 90-degree angle, right? And if they're, or because they're perpendicular, and if they are perpendicular to each other, then they're parallel. If they are perpendicular to the line, then they're parallel to each other, right? So the first statement is the given. So RS, it's tangent to circle A and circle B at R and S. This is our given, right? Number 2, Like I said, we know that the radius, the diameter, it's perpendicular to the line. Both are. So AR, segment AR is perpendicular to line RS. Same goes here. Segment BS is perpendicular to line RS. Is the same reason, right? In this case, we are not going to talk about the diameter. We're talking about the radius. So radii, because both are perpendicular to the tangent line, right? The tangent line. I'm not going to write RS again. So number 3, since they are perpendicular to the same line by the same theorem that we used in the previous proof, then segment AR, it's parallel to segment BS, right? This is because two lines, this is because the same thing, two lines perpendicular to the same line, are parallel to each other, right? So this is the idea for this proof. It's basically the same as the previous one. All right, this one is a little bit more interesting. So we have again our statements, and we're going to list our reasons. So like always, the first one is going to be the given. So I said, assuming construction of the dotted lines, complete the following proof. Given lines from P tangent to circle R at points A and B. So we know that P, that lines from P, from point P, are tangent to circle R at points A and B. So that means that PA, and PB are tangents to circle R at A and B respectively, right? So this is the given. Okay, so if you notice, let me use a different color. If you notice, this is a radius because R is the center of the circle. So this is also a radius. So we know that these two things are exactly the same, right? And since AP and BP are tangents, we also know that this is a 90-degree angle. So we're dealing with right triangles, right? And since we are dealing with right triangles, and we know that this is a common side, right? By reflexive property, we know that they are sharing this side. Then the two triangles are congruent. And if they are congruent, then we know that everything everything that is corresponding it has the same measurement, right? So we're proving that PA is equal to PB. So that's basically our plan, okay? So, all right, number 2, AR, it's congruent to BR because the radius, right? So the radii of circle R, right? We know that angle RAP, it's equal to 90 degrees, and it's equal to ABP, angle R, RBP. Okay, this is because radius, it's perpendicular to the tangent line, or a tangent segment, tangent line, right? We know that. So since they're perpendicular, then we're dealing with right triangles. And if we're dealing with right triangles, then oh, my bad. Again, like I was saying that this is a common side. So we know that. My bad. I was forgetting that. So RP, it's congruent with RP by reflexive property, right? Reflexive property. And now that we're dealing with right triangles, and we know that the hypotenuse and the length, leg are congruent, then we know that the two triangles are congruent. So we know that triangle ARP, it's congruent with triangle BRP, right? This will be by hypotenuse leg theorem. And finally, since they're congruent, then by CPCT, we know that AP it's congruent with BP. This is basically by CP, CT, right? Corresponding parts of congruent triangles are equal. That will be the proof. I think that this is the harder proof in this bunch of problems. Let's see another one. In this one, it says, given AE tangent to circle R at A and to circle S at E, prove that the angles R and an angle S are equal. So again, statements and reasons, right? So first, again, the given AE, it's tangent to circle R at A and to circle S at E. This is the given. All right, what kind of information we can get from the figure? Again, if you notice, this is a radius, so we have and AE is a tangent, so we know that this is a right angle because they're perpendicular. The same goes with ES, so this is a 90-degree angle. Also, we know that we have this two vertical angles. They must be equal. So you know that if these two angles and these two angles are equal, we know when we study angles, we have a theorem that states that angle R and angle S must be equal to, right? So if this is 90 and this is 20, this must be 70. And if there are the same measurements, then this must be 70, okay? So that's basically our plan. So number two, we know that, again, that this is a right angle and this is also a right angle. So angle, well, actually we can put it, yes, let's do it with angles. So angle A, I think it's pretty clear that we only have one angle A that matters. It's congruent with angle E because it's also clear. And this is because radii are perpendicular to the tangent line. Okay, we know that. Number three, again, we know that angle C is congruent with angle C by vertical angles or reflexive vertical angles. This is basically the same thing. And since the two of them are equal, then again, we have a theorem that state that angle R must be equal to angle S. And that's what we need to prove. This is because if two angles of a triangle are equal to, well, it's not going to fit here, but basically what we're saying is if two angles of a triangle are equal to two angles of another triangle, then the third angle must be also equal. It must be congruent. Okay. All right, let's go for, I think this is the last one. No, we have two more. All right, so, all right, this one, it says two concentric circles with AB tangent to small circle R prove that AR is equal to RB. So basically the idea is to prove that this piece here, it's equal to this piece here. It's pretty clear that OR is a radius, right? And since AB is a tangent, we know that we have a 90-degree angle right there because they're perpendicular. Okay, also, we know that this AO, let me use a different color since we have already red on the picture. So AO, it's a radius, and OB is a radius, but of the big circle. And we know since they're radius that they're equal. So we know, again, basically, we have a right triangle, hypotenuse leg. They are congruent. And if they are congruent, then by CPCT, everything else is going to be congruent. It's going to have the same measurement. So the only option is that AR is equal to RB, right? So statements. So we have our statements, and we have our reasons, right? Okay, so let's just start to write that thing down. So we have two concentric circles, two concentric circles with AB tangent to smaller circle R. This is our given. All right, so radius OR, it's perpendicular to AB. Again, we know this because radius is perpendicular to tangent line, right? We know that. So since that happens, then angle, let me put it here since I'm short on space. ORB, it's equal to 90 degrees, right? Okay, but radius or radii OA and OB are radii of the big circle, so they're congruent. So OA, it's equal to OB, right? The radii of the big circle, right? Whoops, circle. All right. And since they're equal because they're radius, then like I said, we have two right triangles, right? And by hypotenuse leg, the triangles that we just formed are congruent. So triangle ARO, it's congruent with triangle BRO. And this is because hypotenuse leg. Basically, we have the hypotenuse, this blue line, right, and the leg with the green line. So by hypotenuse leg, they are congruent. And if they are congruent by CPCTE, then AR must be equal to BR. This is by CPCT, right? Okay, so that is our last problem, I think. Okay, no. We have another one. We have another one. This is the last problem. Okay, in this problem, it says, given the, let me choose a different color. Given, actually, let's choose that one. The measurement of angle XOY, it's equal to the measurement of WOB. So what we have is that XOY, this one, is equal to this one, apparently. And also that the measurement of the arcs, this arc, it's equal to this arc. Okay, this is what they're saying. Let me use a different color for that one. So this is equal to this. Do we have a different color here? Yes, let me use orange. Or whoops, that's like way too thick. All right, let's put it there, I guess. So this, and that's almost the same thing. Okay, so we have those two things are equal, right? And if they're equal, and we have central angles here at center O, we know that these are equals to, right? So we're going to prove that XC, the whole thing here, is congruent with the whole thing here. But since we're talking about angles in the center, we know by angle addition postulate that angle XOY plus angle YOC must be equal to these two. Since they have the same measurement, they must be equal, right? So angle COW must be added to angle WOB, so we have the same measurement, right? And if we have the same measurement, this by the angle addition postulate, this is basically this right here is basically XOC, right? XOC. This is angle XOC, and this is angle COB, right? And if we know if we know that we are adding equal things, and we now establishing that XOC is equal to SOB, and let me erase this real quick. We know that XOC is this, and that is a central angle. So that central angle makes this back here the arc, also with the same measurement, right? Because we have a theorem that states that if we have a central angle, then this arc is going to have the same measurement of that central angle. So this is basically arc XC. Let me use a different color. Arc XC, right? And SOB is basically this, right? SB. So this is arc SB. So we just established that the measurement of arc XC is equal to the measurement of CB. This is an informal proof. In this case, you should try to write this down like in a more formal way using statement and reasons, but you already have the whole plan. I just gave you everything. You just need to write it down properly. So I hope that this video is helpful studying for the unit test. If you have a question, let me know in the next class.